Okay, we're almost done with chapter 30. I'm telling you the story, the tales of woe when you don't have things labeled. So almost all of our servers had two redundant power supplies, so they had two cables coming out of them. And so I really need to label the power cords, so that I labeled them at the top where they plug into the servers and at the other end when they plug into the ups. So I had these little labels on each end of the cable. Yeah. We use color coding on the network cables. Dirty was red. Coming off of the main feed going into our firewall was a red cable. And then we used blue cables and other different types of cables. So coloring and labeling is extraordinarily important. You don't ever want to accidentally jack in the dirty part of the network on the other side of the second, the other side of the DMZ. And quite frankly, we even, just as an extra safety measure, we made sure that cable wouldn't reach to the clean side. Yes, you had the dirty side up here at the top, and then the clean side, but down here, that red cable was short enough that it could not be plugged into the wrong end. Just saying. Okay, so let's switch over to a different topic on page 31, which is a thing called DevOps. It's a strange term, but here the title is Methodology, Policy, and Politics, page 1105. So, one philosophy is to increase stability. You need to minimize changes. That's one way of thinking, right? In order to make things more stable, we ought to not allow any changes. Now, in our world, that's kind of dumb. So change minimization, that philosophy has horrible, horrible consequences. And you can end up with a technical deficit or a technical debt where you are so far behind. A classic example is those companies that's still running over some ancient mainframe running a COBOL application for their payroll. And they figure, well, everyone knows this stuff and we kind of like it and there's no need for us to swap this stuff out. Oh boy, yes there is. There's a legitimate reason for swapping this stuff out. So, and you might think, well, nobody's using COBOL now. Yeah, they are. Yeah. And typically they're like state agencies or federal agencies that just don't have any money. Companies realize the risk, and companies will go, holy moly, we just can't have that. So, we're going to spend money. But nonprofits and small government organizations, they don't have the money, so they're probably still running some COBOL thing somewhere. On page 1106, they start talking about the DevOps philosophy. And so let me explain a little bit about a story. So here's a story. The story is that you have a separate group that does the development of a particular piece of software. Then you have the people who actually operate it. So you have the developers and the operators. And a common thing that happen is somebody will complain that this ain't working, and there's going to be a squabble between the program is broke or you didn't configure it right. And so you end up with this battle. Worked fine in dev, so it's somebody else's problem now. That's kind of a cool way of looking at it. Now, this is obviously system administrators and other operators were separate from the development. And so there's an awful lot of conflict. It's just human nature to say, I write stuff, and when somebody comes to me and says, I found a bug in your program, my first reaction is, shit, I bet it ain't true. Okay, that's my first impact. And then I have to humble myself and say, well, okay, it is possible that I've made a bug, and let me go see if I can fix it. But my first instinct is a kind of an emotional, bullshit, I don't believe it kind of a thing. So, human nature. All right. So, in order to bring these things together, what you ought to do is not have them apart. I know that sounds dumb, but you ought to have one team with one team manager, one supervisor. If you had one team that done development and had a supervisor, and one team that did the operations and had a supervisor, we're going to complain to each other like this, But if they were all working in the same team, in the same room, with the same goals and the same supervisor and the same performance ratings, okay? Then that kind of makes a difference. That's what we're all about. So, they talk about, well, what is DevOps? Well, it's easier to talk about what DevOps is not. Okay, it's not an environment, it's not people, it's not job titles, it's not tool, it's not team. It's an overall operating philosophy, which could result in how you configure a team, but nevertheless, this is kind of interesting. So there's a thing they talk about an acronym they use to describe this. Excuse me, called CLAMS. Okay. Whatever. So the first one is culture. So everyone works together for a single business goal. In other words, my goal is the same as your goal, right? I'm a developer and you're an ops guy, a sysops guy. Well, then our goals should be the same. Yes, you're probably going to have maybe some reporting structure differences. Maybe not. So, have you, in the old days, if you had people on call, and I got called in the middle of the night, it was always going to be, it's a hardware problem. I'm a developer. You called the wrong number. And so they call the hardware people and they go, well, it's a software problem. You called the wrong number. Right? You just battle back and forth. So essentially what you have to have is you have to have a team. You have to have, a software guy and a hardware guy both showing up to solve the problem regardless. So you can't say, oh, it's a hardware problem. Okay. So one of the features of the culture is I'm developing a culture so that nothing moves from development to production without some testing. And that there's a production environment that kind of mirrors the development. You don't ever want to have a scenario where you're making changes to a live system. Okay, that's just dumb. I need to have a parallel version of the live system. In my case, we had virtual machines. So we didn't mess with the real domain controller and the real file server and the real web server. We had virtual ones down here. So if I'm developing something on my machine, I deploy it to this virtual thing to make sure it works. And then we deploy it up to the production if everything is okay. The ops people get invited to code reviews. Yeah. I have regular joint meetings. We don't have just meetings for the developers and just meetings for the hardware folks. And we have a combined communication system like a chat room or some sort of a SharePoint thing where you pass things back and forth. We're trying to close the gap between the two. The L in CLAMS is lean. Lean meaning I need real-time interaction. I need, not static meetings where everybody goes and just sits and listens, right? Let me tell you what happened this week, in a staff meeting where everybody just sits around and just takes notes. No, it needs to be a communication where everybody talks about what happened this week, kind of a thing. A in CLAMS is automation. Basically, if you're going to do something more than once, then you probably need to script it to make it a little easier. Just saying. There's a lot of advantages in scripting things. If it's a mundane task that just nobody likes to do, well then script it. It reduces the risk of human errors, right? You can't mistype it. It captures procedures in written form. You can look at the script or look at and think, oh, this is exactly how you do it. Cool. It facilitates an evolution, for example, like a fallback plan and things like that. And it achieves scale. In other words, if we were to double the number of servers, this little script would work on each one of the servers. Okay, so here's some examples of where you can use automation. So I get a brand new shipment of PCs from my company, and on the loading dock is a handful of cardboard boxes. Each one of these things has to be configured. I could do them all by hand. I could load the operating system and all of the office applications and all the line of business applications and configure them all the way I want. That would probably take a while, and quite frankly, there'd probably be a small differences between machines because maybe I did something in a slightly different order, Or you can have it all automated where I line them all up, jack in the network cables and hit the thing up and boom, deploy all of them simultaneously, hands off, don't have to touch, and that way they're pretty much will guaranteed to be absolutely the same. Kind of cool. So configuration management is something that you need to spend time on. Probably have a server configuration management thing, and then a workstation, and then regular PC configuration on how you configure machines. I have a system of promoting code. In other words, it goes from production, goes from development to testing environment, and then from a testing environment into the production environment. You really need to have this promotion. I've got something going that needs to be promoted over to testing, and only after it finishes testing gets promoted over to full operation. Yes. And then, how do you patch things? That'd be another one where automation is kind of simple. A technique for doing, Patch Tuesday kind of thing. Do you deploy the patches immediately, or do you send them off to a select group and have them tested, and if no one complains, then you put it out to the rest of the world? M in CLAMS is measurement. The idea is that I need measurements for baseline data. I need to know when you deploy a brand new server, let's say it's a database server because that's just easier to talk about. I have a database server, and I'm running simple queries against it, and I'm recording how long it takes. It takes 140 milliseconds to get a response to this type query. And so you write all that down. And so you measure these things. And so once a month or whatever, you measure how it's doing. And you put it on a chart. And eventually it's going to start to get slow because of, the amount of use. Number of users on there, or the database has grown. Doesn't really matter why. But the performance is beginning to drop. And so you have to be measuring these things. Well, rather than saying, well, okay, on the first of the month we're going to do this, we'll just have it automated. Have these things automatically being collected and doing all that stuff. And so you don't have to, all you have to do is start analyzing the results. You don't actually have to do anything. And then the S in CLAMS is sharing. The idea is if you come across something good, for God's sakes, tell people about it. Good ideas spread pretty doggone fast if you do it. If you don't do it, well, then you're an idiot. Oh, did I say that out loud? Okay. So, system administrators in a DevOps world. So here are the things that they would do. Building, configuring, deploying infrastructure, ensuring an operating system is safe. In other words, the patches, that kind of stuff. Deploy tech for continuous integration, deployment, monitoring. That's kind of an interesting thing. You need this continuous deployment kind of a thing. It's not going to be, deployment stops and then something else happens. It's this continuous thing. Coaching, yeah. Mentoring, monitoring and maintaining infrastructure. Responding to users' requests. Okay, fixing problems and planning for future and all the rest of these kinds of things. Look at the last one, though. I think it's kind of cute. Maintaining emergency stats of ibuprofen, tequila, and other chocolates to be shared with team members for those who are not so fresh days. The author is having fun with this chapter. Okay, so one of the things it talks about is fixing problems as they occur, responding to user requests. So you need a ticketing system, okay? You need some ways for somebody to go in and request a service. It gets an urgency and a category, and it gets routed to the right team. All that stuff's behind the scenes. And so there's an awful lot of these things. Basically, in my world, if there is no ticket, then the problem does not exist. Well, how come you haven't fixed my printer? Did you put in a ticket? Well, no. Well, then you've answered your own question. Unless there's a ticket, there is no problem. I'm sorry. You need to put in a ticket. Okay. So what are the advantages? The advantages of a ticketing system is, you probably won't be able to have too many things fall between the cracks. I forgot to do that. Doggone it. There's probably no less duplication of effort where two different people were asked to solve the same problem, right? Person A doesn't even know that person B is working on the same thing. And the tracking system for system health and staffing, you could use the tracking system to say, I need more staff. We're being overrun with all these requests. But if all you do is just wave your hand saying, man, we're really, really busy, But if you had a system in place, you could say the average wait time for a non-emergency is 14 days. And that's not acceptable to our customers. We need to have more staff. You could provide them critical data. Okay, we're coming up on the 15-minute mark, so we'll continue this discussion in just a minute.